Hello, good day everyone. So today we will be discussing about functions. Okay, functions relate an input to an output. Function notation, this can be read as y is equal to the f of x, where the output here is y, and f of x, or your function f, name of function, and your input inside this parenthesis is x, which is our input. So functions in real life situations. So for example of functions is the input is the number of hours you studied, for example, for exam. And then the output here is your score in the test. Okay, now let's proceed to functions definition. Is a relation in which each element of the domains is paired with exactly one element of the range. Another word of saying it is that there is one and only one output, which is y, with each input x. So we can illustrate functions by using of the following: set of ordered pair, mapping or arrow diagram, and graph. Okay, so as I said earlier that function can relate to an input then output. So your x or your domain, which is the set of inputs, so when you encode these inputs into a machine, so for example, this is your f of x. So this machine, if you is your f of x, for example, let's say x squared. So the machine tells what your inputs need to do. And then we have the range or the y values, that is the set of outputs. So your outputs, uh, it is the final product after the inputs be in process inside our function rule. So now we have our outputs. So this is the function maps its domain onto its range. Okay, so for example, this coffee machine. So after putting all the ingredients inside this container, of course, so the output now is our finished coffee. Next, okay, so let's proceed to another example of machine. So for example, this vending machine, for example, the green bottle worth 20 pesos, and this red bottle worth 30 pesos, and the orange is 50 pesos. So when I insert a bill amount of 50 pesos, what will come out? Of course, the orange one. If I input 20 pesos, the bottle that will come out is the green one. So that is the output. The input here is the money you insert, then the output is the drinks that you wanted according to its price. Okay, so as I said earlier that a function can be represented using set of ordered pair x, y. So your first element here is the independent variable x, also known as the domain. And then the second element in our ordered pair is y, also known as the dependent variable or the range. So for example, in number 1, or the set of ordered pairs, we have here 3, 2. The next pair is 4, 0, 5, 1, and 2, 3. So it is a function. Why is it so? Because we have only one input in we have only a unique input in each output. So take a look that it is a one-to-one function because one input rather has a one output. For example, the input is 3, then try to look if there is another input 3. Okay, so we only have a 3 as our input, then try to look at its output. So the output is 2. Next, our input is 4. So 4 here, the output is 0. Then input 5, the output is 1. Then input 2, the output is 3. Okay, next, let's proceed to second example. The input is 1, the output is 2. Then the input is 0, the output is 3. The input is 1, and the output is 6. The input is 5, the output is 4. So it is not a function. Why? If you notice, here we have the same inputs. So take note, in a function, it is not possible that we have the same inputs. So it is possible to have the same output for different inputs, but it is not a function when two inputs are the same with different outputs. Take note of that. So that's why it is not a function. Okay, now let's proceed to example number 3. So for example number 3, our input here is 3, then the output is 4. Our input is 3 again, then the output is 0. Input is 3, the output is 1. The input is 3, the output is 3. So why is it that it is not a function? Of course, again, we have only one input to each set or set of ordered pair, then we have different outputs. Take note again that we cannot have the same input or the x value in our function. Next, let's proceed to our example number 4. Okay, so we have here the set of ordered pair. The input is 4, then our output is 2. The input here is 3, the output is 2. The input is 6, output 2. Input 5, output is 2. So it is still a function. Although if you notice that our output is the same, still that is a function because we use different inputs, so our inputs are not repeating. So it is okay that our output is repeating or the same output with different inputs. So it is still a function. So that is the rule of a function. This is also known as many-to-one function. Many inputs but one output. So still that is a function. Okay, so let's have another example. So since I am your teacher in Gen Math and I handled 4 sections in UMS, so these are the sections that I am handling in UMS. So UMS 11C, your teacher in Gen Math is Miss Larissa. For UMS 11B, your Gen Math teacher is me again. Then for UMS 11E, your teacher is me again in Gen Math. And for UMS 11F, your teacher in Gen Math is also me. So it is still a function because the input here is the class section. So we have a different class section and you have the same y values or the range or the output. Okay, next we have another example of not function. So the teacher in Gen Math and the strand in section I am teaching. So Miss Larissa and the strand she is teaching is ABM 11B, then me and the ICT 11C, and me and ICT 11D. So it is not a function because take note the input here is repeating 3 times. So it must not be repeated. Although I have a different outputs, but the input must not be repeated. So this is an example of one-to-many relation rather. Okay, next, functions can be represented through a diagram. So, or a mapping, one-to-one mapping diagram or a mapping diagram. So, here's an example of a function. So, the first set here is your x, element x. And then the second here is y. The y sets or y elements also same here. Then, so try to look at our first element. So if you notice that they are functions because our input here is 3, then the output is only 1, which is A. Our input is 4, the output is B. Then input is 5, then the output is C. Still, we have a unique input and also a unique output. So this is what we call one-to-one function. So one input to one output. So that is a one-to-one relation or function. So it is a function. Next, let's proceed to another example. Your input here is 2 and then the output is 9. Your input is 3, the output is also 9. The input is 6 and the output is 4. Still it is a function because no y values that is repeated. So it is still considered a function that is in case of many to one relation. So many inputs with one output. So that is still a function. Next, we have here an x value which is 3. Then its outputs are 2, 3, and 6. So it is not a function because this is what we call the one-to-many relation. One input with many outputs. Okay, next, let's proceed to the last. This is an example. This is not a function because not all elements are presented. So take note that an input should have an output. That's it. Okay, so this is the easiest way of presenting or knowing that it is a function. So if any vertical line passes through more than one point of the graph, then that relation is not a function. So we call this vertical line test functions. So we have here our function y equals x. So this diagonal line is our function. So we draw a vertical line, the red one. So we draw this to test if the graph is a function. So if the vertical line passes through the graph at only one point, then therefore it is a function. So it passes throughout here at exactly one point. So therefore, this is a function. Next, let's proceed to another example, which has the equation of x squared plus y squared equals 4. So take a look when the vertical line passes through the graph. So if it passes through our graph, take a look how many times did it pass to our graph. So we have 1, then we have 2. So it passes twice to the graph. So therefore, this is not a function because a function, using a vertical line test, it must pass the graph once, not twice. Okay, next let's proceed to our last example. Why is it not a function? Take note how many times did it pass to our graph. Okay, so it passes to our graph twice. So therefore, this is not a function because it passes to the graph twice. So we have here the 2 points that the graph or the line passes. So let's have a very quick review about piecewise. A definition of a piecewise defined functions. So a piecewise defined function is a function that is defined by two or more equations over a specific domain. The absolute value function given by f of x equals The absolute value of x can be written as a piecewise defined function as follows. So kindly look at your modules. You have there the graph of an absolute value. So that is an example of piecewise. Okay, so I have here an example of graph of a piecewise defined function. So we have here three functions, that is x plus 4, the second is 2, then the last function is x minus 5. So they have a different specified domain. So this is an example of piecewise, but we will not be discussing more about it because our main topic here is the function and different types of function for the next week. That's all. Any questions? So if you have questions, just message me in our group chat. Also, you can comment here. That's all, and thank you for listening, and keep safe everyone. Thank you.